Hello, MOS 4472 team. In this video, I'm going to take you through chapter 18, which is our data visualization chapter. We will discuss attractive data visualizations, the stories that we want to convey using data visualizations, and the different types of data visualizations we can use for different types of data and different messages we want to convey. So let me share my screen with you. Okay. Okay, data visualization. So in this chapter, we're going to look at the relationship between storytelling and data visualizations. We're going to learn how to apply some design fundamentals, explore data sets using visualizations, and use data visualizations to present insights to decision makers. So our learning objectives are to summarize the importance of user-centric design and storytelling in data visualizations, apply fundamental design principles to data visualizations, evaluate visualizations techniques for exploratory analysis, and then describe visualization techniques that are used to create explanatory stories. Let's start with the first objective. So here we see a visualization of the world's population by continent. And as you can see in this visualization, we see both the use of color as well as numbers to show. So we see small populations are lighter in color, and then the more dense populations are darker in color, and we can easily see that most of the world's population resides in Asia, where according to this chart, we have 4.6 billion people. In contrast, the least of the world's population resides in Australia, Oceania, where we only have 42 million people. So that's a really good visualization that you can obtain a lot of information in an easily and accessible way. So data visualization, from the purposes of our textbook, the definition is a data analytics technique that presents data in a graphical format, such as a chart or graph for analysis and communication. Creating a high-quality visualization requires certain things of the designer, such as understanding the audience and their requirements. It's very, very important to understand your audience. You will show data very differently to a CEO versus a sales manager versus a marketing manager. You have to use fundamental design principles to create user-friendly visualizations. You have to be attuned to color, font size when you are designing your visualizations. You have to understand the data and select the appropriate visualization technique. So you need to know when to use a heat map, when to use a bar chart, when to use a pie chart, where to use a line graph. And then you have to put all these concepts together to create and develop an appropriate visualization that shows and tells your key message. As I mentioned in our first class, with data visualizations, we are acting as storytellers, and we need to make sure that we tell a true and accurate story that the audience can understand and make decisions from. So turning data into a story, there are many ways to create data visualizations. Many information systems, including ERP systems, have built-in reporting modules that can generate some of the basic visualizations. So you might have KPIs already built into your ERP system, such as Oracle's one ERP system that many organizations use, or Alteryx. Alternatively, you can use data visualization software like Tableau and Power BI. to capture data by the system. We are going to spend next week looking at Power BI. Here's a raw data example. So it looks like we have sales data for the year by month. And here we see that the visualization was presented using a line chart. And what we don't know is what are the lines representing? Is one a forecast and one actual results, or are we looking at two different years? It says year one. So we can see from this example that we really need more labels or a legend to tell us what these lines mean. Designing for a user, there's an art to creating dashboards that are beautiful, intuitive, and more importantly, user-friendly. The first step of any data visualization project is knowing your visual audience, which includes all the end users of your data visualization and understanding their requests. So remember, you need to really understand the user and what they want to know. You're going to show different information to a CEO than to a client, than to a production manager. Determining a visualization audience, it's important to ask the following three questions. Who is the end user? How will the visualization be used? And then what are the technical user requirements? So in this case, you need to understand the user. You have to design different considerations, whether the data is going to be just in a PowerPoint presentation, or is it going to be presented as a dashboard on Tableau or on Power BI that will enable your users to drill down. And you need to understand the technical requirements to make sure that your end user knows how to use these dashboards. Importance of visualization audience. Overlooking the audience when creating a data visualization is a huge mistake. Data scientists, data analysts, or data engineers may know advanced data analytics techniques, but they might not understand certain principles such as what a business presentation needs in order to be effective, how a business stakeholder may interpret the visualization, the appropriate level of detail for the business need, and the value of white space. So this is where we as accountants come in and can add value. We can take the data that these data scientists provide us with and make them into user-friendly presentations that are focusing on the business stakeholder needs. Setting the tone. Subliminal messages and data visualizations influence end users by conveying emotions. A well-crafted visualization sets a tone the audience members will remember, even if they forget the exact number. So the picture tells 1,000 words. So remember, the types of colors and fonts you use are important. Setting the tone of a data visualization allows end users to feel the data as they read it. A great data visualization strikes a balance between providing facts and communicating the desired emotional response from those facts. So think about it. If you are doing a fraud presentation that uncovers a major fraud, you want your tone to kind of set alert. You want to raise the alarm, right? Whereas if you have a presentation that's showing that the company achieved record profits, you want that presentation to be happy and exciting and everyone to be proud of how well the business is doing. Visual cue example, 1.2 million duplicate vendor payment. So in this case, the red is kind of stopping the user and setting the tone that, oh, there's a problem. Next, we're going to talk about applying fundamental design principles to data visualizations. So data visualizations, like all other visual clues and graphics, are based on design concepts. A design concept is the central idea or theme that drives a design, meaning, and tone. In business, professionals who work with visual cues, like data visualizations, pay careful attention to details to ensure that different elements of this design work together to tell the appropriate story. Especially for designing a dashboard, we have to make sure that the various charts and tables we put into it integrate well together, and the color scheme is cohesive and user-friendly. So color is one of the most important decisions in designing concept. Colors draw attention, they incite emotional reaction and determine the tone. There are two families of colors. We have our warm colors such as red, orange, yellow, and those are, at least in Western society, associated with joy, energy, and playfulness. And then we have cool colors such as green, blue, and purple, and these traditionally evoke relaxation, calm, and stability. A word about red: in business, red usually means losses, so we have to be careful how we use red. So here we have the warm color family and the cool color family, and you can see the differences in the colors. Color pairings: a color wheel, which is a useful tool for design, shows relationships among colors and represents different combinations a designer can choose from. And this just makes sure that the chart that you're making is easy to understand. The worst thing you can do is have 4 or 5 colors that are just similar in shade, because then it's really hard to differentiate which color denotes which, let's say, department or which geographical region. So it's really important to make sure that there's enough contrast between the colors so that you can identify differences. Designers often also use gradient or shades of a single color to create minimalist designs. The best practice is to limit the number of color used in a single visualization to no more than 4. If you have 4, it might be cluttered. Using too many colors can create visual chaos and make it difficult for users to understand the message the visualization is trying to convey. But also be wary of using too many similar colors. So here are some color wheels. Complementary two tones are green and red. Think of a traffic light. Then we have some analogous. So we have blue, dark green, light green. Here we have triadic. We have split complementary, and we have the tetradic. And there's color wheels all over the internet that you can Google and look when you're creating your charts. So this is a poorly colored visualization. It's a mess. There's, blue, there's teal, there's orange and blue. It's very hard to read, especially from like the site report part. So it's important to make sure that your picture is sharp and understandable. Color psychology: different colors convey different emotions. Color psychology is the study of human behavior related to colors. Every color is associated with positive and negative traits, and colors can influence human perception by evoking emotions. So remember, from a psychological perspective, we have an affective system, which is our emotional system, and then we have our cognitive system, which is the thinking systems, and these systems interact, and emotions influence our thoughts, and our thoughts influence our emotions. North American color psychology: when you think of red, you think it's noticeable and bright. It has negative business connotations because we always look at losses in red. Black Friday has come about because that's the day where companies actually start making profits. So everything, when you say the company's in the red, it means that it's in debt. Positive qualities associated to red are love, confidence, power, energy. Negative qualities are anger, aggression, negativity, failure. Then we have orange, which can suggest adventure and fun. It's used in children's products. Positive qualities of orange is creativity, enthusiasm, vibrancy. Negative qualities include cheapness, superficiality, and insincerity. Then we have yellow, which draws attention, but more subtly than red. Yellow is used often in children's products. It highlights important information by drawing attention. Think of using a highlighter in a textbook to highlight important information. Yellow is associated with happiness, fun, and optimism. The negative qualities of yellow are egotism, cowardice, and criticism. Then we have green and blue. I will let you read about those colors. Be mindful, and then lastly, purple. Be mindful of these colors when you're creating your visualizations. Color accessibility. Accessibility is one of the most important color decisions to consider, as not all sighted people experience color the same way. Since accounting data is numeric and often financial, it's natural to want to use green to indicate positive numbers or increases and red to indicate negative numbers or decreases, but the message will be lost on someone with color vision deficiency. CVD is most commonly referred to as color blindness. So as the first thing we talked about in this chapter mentioned, know the user of your financial data and know if they have any accessibility issues, and make sure you design your visualizations with the end user in that mind. So here's a CVD illustration. You can see how a person who isn't colorblind sees color versus someone who is colorblind. It's quite different. Accessible tips for persons with CVD. Use CVD-friendly color combinations. A common combination of CVD-friendly colors include shades of gray along with blue, orange, or blue and red. Select different tints of the same color. Using light and dark shades of one color allows an end user with CVD to associate the darker tints and lighter tints with differences in the visualization. Explore alternative methods to distinguish data and visualizations. You can add text, icons, arrows, annotations, different line width, or different line styles, such as solid versus dashed lines. I always recommend this when doing line charts. Even from a printing perspective, if someone prints your presentation and they don't have a color printer, you want to make sure that they can still distinguish which data is which. So here is a CVD friendly palette. We have dark blue, light blue, we have red, we have orange, and we have gray. And then we have different shades of the same color. As you can see, one of the problems is this shade is very similar to this one, and this one's very similar. So you have to be really careful how you group similar shades. And it also helps to use labels so it's easy to identify what the actual color denotes. White space, white color is important, so is its absence. A cluttered data visualization distracts the end user from its intended message. White space is negative space that creates a visual pause. So if you're looking at something that's really bright, it can be distracting. White space allows our mind to rest and truly focus on the data and information that is in color and you want the person to look at. It allows end users to process a visualization message and reduce cognitive load by eliminating unnecessary elements and distractions. Its use is also considered modern and visually appealing. White space, less is more. The white space motto is less is more. In other words, visual simplicity is often more effective than visual complexity. Importance of white space. White space is important when creating visualizations for many reasons, including Comprehension, it eliminates distraction visual elements, which improve understanding. Simplicity, you avoid overwhelming your reader. Focus, you can highlight key information. And keep in mind that overusing white space can indicate a lack of content. So be mindful with white space. Too much can be a cue that you didn't do enough work. And then it's important to find the right balance. Removing clutter using white space. Here we have two different graphs communicating the same information. However, by taking away grid lines and reformatting material, this graph is much more visually attractive than this one. Typography describes the style and appearance of printed matter. One aspect of typography concerns the font choice for a visualization. Fonts influence the tone of a story, and using a professional font increases the credibility of a visualization with the audience. Fonts should be readable even at small sizes. So you have to make sure that your audience can read what you put. So be mindful of your font. Popular fonts choices include Benton, Fira Sans, Gotham, Nodo Sans, Source, Sano Pro, and Merriweather. I like Times New Roman. However, these are the ones that are most visually appealing from a perspective of visualizations. Approaches to implementing typography. There are different approaches for implementing typography. One approach is using one font and one size of font, using the same font and font size throughout a visualization creates a consistently subtle and modern visual impact. On the other hand, you can use one font and a big header. Using a single font with a larger header highlights the header or titles of the visualizations for the audience. So you're drawing your audience's attention to the header. So you're telling them, this is total sales by year. And then the smaller font might have like 2020, 2021, 2022, for example. And then you can use two fonts and with different emphasis. So using two complementary fonts with the header bold draws attention to different parts of the visualization. So you can differentiate a visualization by using different fonts. Iconography. Iconography is the use of visual images and symbols to present ideas. In data visualization, icons are symbols that provide visual cues along with data, text, or charts and graphs. An icon directly communicates information without distraction. Here is an example of an icon. Icons are being used more than photos now because photos can be blurry, different resolutions, whereas an icon is very clear and the simplicity of the icon doesn't take away from the message or distract your user. Advantages of icons over photographs. Icons have an advantage over photographs in that photos can distract the audience from the message of a visualization. For example, they might show people wearing outdated clothing. They might depict unconvincing behavior. They might be dull or overly dramatic. They may lack diversity or accurate representation. So disadvantages of stock photos are that they're often unconvincing and unrealistic. So I've never seen people hype up each other like that in a meeting. Maybe one high five, but a group high five seems a little cheap. Okay. Our third objective is to evaluate visualization techniques for exploratory analysis. By turning raw data into a visual, we can easily perform flexible and insightful descriptive and diagnostic analytics. In visualization, we call this process of investigating unknown data exploratory analysis. So in exploratory analysis, we explore unknown data. So here is an example of an exploratory analysis. We have bar charts that compare all stores to San Francisco store 201. And then you have various indices such as delivery, reactions to cookies, selection of flavors, etc. So you can see how the store is doing versus other stores and areas in which they are succeeding and areas where they fall below average. Techniques for exploratory analysis. Data visualization techniques can be used for exploratory analysis to answer a number of questions. For example, you can learn about the composition of the data, what variables are included in the data set. You can look at the comparison of different data points. How is one variable performing compared to other variables in the data set? You can look at the distribution of the data. How often does a variable occur within a data set and what is the variable range? You can look at relationships between data points. How do the different variables in the data set relate to one another? And you can also look at the geospatial location of data points. Where are variables geographically located in a data set? So composition and comparison. Understanding data composition includes answering questions like, what are the categorical values or descriptive components that we can use to summarize the data for analysis? And also, are there quantitative values that describe the categorical values with numbers we can then analyze? So pie charts are one type of data visualization. They're one of the basic visualization, which divides data into groups proportional to their size within the data set. While pie charts are common, they don't always paint the clearest picture. Our human brain is not trained to compare angles of pie. For this reason, it can be difficult to correctly gauge the comparison between slices of a pie. However, there are things we can do to improve pie charts, such as labeling the pie charts to show the actual percentages, showing which labels are referred to, and then grouping the pie chart from largest to smallest so you can actually see the distribution. So this provides a lot more information than if I just showed you the chart without any labels and just a mishmash of slices. Tree maps. One popular substitute for a pie chart is a tree map, which is a mosaic chart that presents groups and subgroups as rectangular portions of a larger whole. So the advantage of a tree map is that you can have multiple subgroups within a group, whereas with a pie chart, if you have subgroups, you would have to have different pies for each group. The key difference between a tree map and a pie chart is that a tree map can handle multiple groupings of categorical values, such as hierarchies. A tree map is useful, quick visual reference to a data set. Due to the rectangular shape, a tree map makes it easy to interpret proportional sizes. Here we have an example of a tree map, and the tree map is looking at different complaints. We have complaints about food quality and the number of stores that had these complaints. Then we have customer service complaints by store. We have timeliness complaints, and we also have cleanliness complaints. Bar charts, pie charts, and tree maps show the breakdown of categories within a data set as part of the whole, making them ideal for both composition and comparison. So you can know the composition of the data and compare the different subgroups. In contrast, traditional bar charts present categorical data as rectangular bars with heights and length proportional to the quantitative values they represent. Because because bar charts display the categories within a data set side by side, they're best used for comparison and aren't ideal for showing composition. So bar charts are good to compare. So you can compare regions, you can compare different product groups by revenue. So here we are looking at different cookie sales, and we have chocolate chip, sugar, M&M's, Snickerdoodle, peanut butter, and raisin. And we can see that the most popular cookie is the chocolate chip, and the least popular is the oatmeal raisin. And there's quite a difference in sales units. We have from 451,000 to 22,000. So that's a difference of about 430,000. And here is a vertical bar chart that summarizes employees by age. One thing that you can see with this bar chart versus this one is with this one, it is ordered based on number of sales from smallest to largest. And this one is grouped by the age ranges. So it's chronological. So you have people that are less than 20 to people that are more than 71. And then we have stacked bar charts. While traditionally vertical and horizontal bar charts don't intuitively display composition, there is another type of bar chart that does. Stacked bar charts illustrate parts of a whole within the rectangular bars of a traditional bar chart. They are useful when illustrating major and minor categories within one category. So here we look at employees by department based on their gender. So we see how many male employees, female, non-binary, other, and undisclosed are in sales, human resources, etc. Heat maps are useful for any type of data where quantitative values can be separated into different ranges or groups. In a heat map, colors are applied from darker to lighter shades based on quantitative values. We saw the heat map of the world population at the beginning of this chapter. A single color and its shade can be used. Gradients across multiple colors can be used as well, such as shades of green, yellow, and red that indicate lower or higher values. So here is an example of a heat map, and we see sales volume called by day of the week and by month. And it looks like Wednesday is the day where the sales volume is the largest. And the smallest days are on the weekend, especially in April. So it looks like July, November, and December have the largest volume of sales, and the smallest occurs in April. And you can easily see this by just referring to the color. Whereas if I gave you a chart with these numbers, it'd be much harder to derive that information. Distribution techniques are used to determine how often a variable occurs in a data set. This is different from comparison in a bar chart or a heat map because distribution is a statistical analysis. A summary of data in bar charts or heat maps doesn't consider the relationship of the data point. In contrast, distribution uses statistical functions to determine the relationships between categorical values and quantitative values. One type of distribution analysis we do is histograms, and a histogram is a visual representation of numeric distribution based on user-defined ranges. It graphs the frequency of values occurring in the data set, so how many times a number occurs. There's defined ranges that are called bins, and they're plotted as bars where each bar height is equal to the number of occurrences of the bin in the data set. The width of a bar is equal to the range of the bin, and all the ranges are the same size. So here is an example of a histogram, and here we're looking at inventory item value, dollar quantity ranges. So how much inventory costs, and they're grouped between basically $0 to $30, items that cost between 30 to 60, 60 to 90, 90 to 100, 120, and this looks like this data set is skewed because it's not normally distributed. Another distribution visualization is the box plot, and this illustrates the distribution of quantitative values for a categorical value. Within a box plot visualization, every category has its own box plot diagram, which identifies the minimum, so the smallest value in the category, maximum, the largest value in the category, the median, the middle value of the category, and then you have it by quartiles, which is the division of the category values into 4 sections. And it looks like a little box with 2 tails at the end. Box plot for anomaly detection. Box plots are useful for showing details within a distribution as well as anomaly detection. The assumption of a box plot is that most of the quantitative values of the category fall inside the box. Values closer to the box are more expected. The further away the minimum or maximum bars are from the box, the more unexpected these values are. So here are the values that would be used in the box plot. We have the different quartiles. We have our median point. And this information then gets put into a box plot. So we have the 2 little tails. One is at the min, one is at the max, and then you see the median and the quartile. And here is another example of a box plot, which shows warehouse receiving clerks and how much they receive. Relationships, discovering relationships between categorical variables in a data set is a common goal of descriptive, diagnostic, and predictive analysis. We already talked about regression analysis in the previous chapter, but we're going to talk about regression again. And regression is used to identify the impact of a value of the outcome of another, to forecast or to predict what comes next. And remember, regression is, we have our dependent variables and independent variables. Next, we're going to talk about line charts. So one of the most popular types of relationships that visualization can explore is changes over time. And in accounting, we look at time series analysis quite frequently because we are comparing our performance to prior periods and we're trying to predict future periods. So a time series captures data that occurs in chronological order across a period of time. Line charts visualize time series analysis, which identifies trends and anomalies in time series data. Line charts are popular because they are simple to understand and can be used for trend analysis, forecasting, and even anomaly detection. So here is an example of a line chart, and we look at different employee expenses from training to attending conferences to customer meetings to sales calls and to meetings. And it looks like the most is being spent on meetings. And then stock bar charts can also be used to compare these expenses, similar to line charts. The problem with bar charts is it is harder to actually figure out the actual amount of expense. You can compare it relative to others, but how much are sales calls? If I look at the line chart here, I can see it's about 5 million. Whereas here it's between like from 6 to 13. So it's 5. So it's a little bit harder to read a stack bar chart than a line chart. Scatter plots, important data analytics techniques that depict relationships also include clustering and classification, which group similar categorical values based on similarities in the data set. The best visualization for depicting these types of relationship is a scatter plot, which shows the relationship between 2 variables. For the purposes of the visualization technique, scatter plots use shapes such as dots or circles mapped along the X and Y axes, which show the two variables being measured for the relationship. So each data point is a dot. So here's an example of the scatter plot. And this one is looking at employee expenses. And you're looking at it by the number of employees and the amount. And what we see here is that these were very expensive undertakings that didn't have many employees participating. So this could be something that you would investigate, whether there's fraud or, maybe there's a miscalculation, or alternatively, a data input error. Then we go on to geospatial maps. So geospatial maps refer to analytics and visualizations that utilize geographic data such as map coordinates, GPS data, and more. Businesses used for mapping geospatial data include, they can show corporate activities such as sales and expenses across geographic regions. So you can map where your sales are happening, and then you can determine, do we need another store in this region because our sales are so high? Or alternatively, maybe we need to close that store because our sales are lower. They can provide insights into distribution of employees, office locations, and customers around the globe. And they can add an easy to understand real world context to corporate data, such as presenting a map that relates corporate risk to physical locations. Here's an example of a geospatial map. And this map draws your attention to the relationship between data and the real world. So we are seeing where revenue is generated. The darker the color, the more revenue. It looks like a lot of revenue is being generated on the West Coast, especially in California. So perhaps the company can open more stores in California. Next, we're going to look at this describing visualization techniques that can be used for explanatory stories. So stories that actually explain what's happening. We were exploring data, now we're using the data and visualizations to explain the situation. Explanatory analysis occurs once the story or purpose of a visualization is known and the data is ready to be presented to the audience. During explanatory analysis, visualizations are crafted, the presentation is fine-tuned, and key points are highlighted. When crafting explanatory data visualizations, remember to consider these questions. Who is the audience? What is the key takeaway from the story? How does the data support the key takeaway? And which visualizations techniques best portray the story? So there's the sweet spot where you're looking at the intersection between the story, the data, and the visuals. Here we have an explanatory analysis is designed to deliver key takeaways of the story being given to the audience. So here we are looking at the San Francisco store and what they underperform versus overperform. So you can see the positives are cleanliness, friendliness, and quality. What they can improve is which cookies they have always in stock. And your recommendation is to monitor your cookie sales from day to day and place your orders frequently to ensure that nothing is out of stock. So this is a nice visualization that tells a story and then also provides some solutions to the areas that have been found to be a problem. Infographic. An infographic is a standalone visual that tells a story through graphic information and rarely needs to be accompanied by verbal communication. Effective infographics quickly engage the audience attention using carefully crafted charts, statistics, quotes, and summarize information that highlights key takeaways. The complexity of infographics ranges from simple single illustrations to a complex large spread. Here is an example of an infographic that can use as a to communicate to people about accounting. You have the top factors that are influencing the corporate cultural shift in accounting. So marketing demands, regulations, generational changes and client demands, and also investments to keep pace. And then you can see accounting is a crucial area for automation. And you see automation is happening more in accounting than in production and operations or even marketing. And then you see the top skills needed by accountants, and technological literacy is one of them, which is why you're all taking this class and learning about accounting information systems and data analytics. So a dashboard is a collection of individual visualizations that allow the audience to view multiple pieces of data at once. A company should perform a cost-benefit analysis when planning a large dashboard project to ensure that the value of the insight that the dashboard provides is worth the investment of time, talent, and other resources. And this is not just a characteristic of dashboards, as we talked about last week. With data, you always have to look at the costs and benefits and ensure that the benefit of the information outweighs the cost of obtaining that information. For accounting professionals, those work often focuses on financial data captured by AIS. Dashboards are commonly used and highly desired for reporting. An example of a dashboard that is commonly used is one that looks at the KPIs or key performance indicators and tracks them and shows whether the company's over or underperforming. Dashboard characteristics. By compiling different visualizations, a dashboard presents multiple key takeaways supporting the overall story of the dashboard. It's important to make sure the visualizations included in the dashboard have certain characteristics, such as they need to relate to one another. You're telling a story, so you have to make sure that the chapters flow and make up a whole, or think about it as the human body. If you're making a dashboard, you need to make sure that it has arms and legs and eyes and ears, and it doesn't have too many arms or too many legs. Each visualization has to support the overall story, so it has to have an added value. Each visualization should be unique and have important takeaways. You don't want redundancy. You don't have to tell the same message over and over. You want to either elaborate further or show different parts. Make sure that the visualizations are necessary and they do not distract from the message that you're trying to convey. So it should, if you're talking about performance and you're measuring performance in terms of sales dollars and sales volume, putting expenses in without cost of goods sold and profit margins would be distracting. Then the difference between static versus interactive dashboards. A static dashboard is a still image with no interactivity, such as JPEG or Tableau dashboard exported into PowerPoint presentation. It's not continuously standing. It's the dashboard or the performance of the organization at a specific period of time. In contrast, an interactive dashboard is presented within the software used to create it or on a website, and it allows the audience to interact with it. So an interactive dashboard has a landing page, which is the first dashboard viewed when the dashboard is open. And then the dashboard allows the user to use different settings and filters to drill down on the information and see what is happening further. So for example, you can have a company-wide dashboard that can then be drilled down by product group or geographical location, and you can drill down to see the actual performance of an individual cookie, like how the chocolate chip cookies performing, or location or store. So here's the landing view example. Here you have revenue by location and by cookie types, and then you can actually drill down click on each circle and then you'll be provided with more information. So here you can see the store here, the Elgin store. You can see their actual revenue and you can see where it's located. Storyboards. A storyboard is a collection of dashboards, standalone visualizations, infographics, and other presentation materials that turn the data analytics and visualizations into a business presentation. So a storyboard is basically a business presentation. When we use a storyboard to present data analytics and visualizations, the storyboard follows the story arc, which has 5 parts. As any essay or any story you've written, you have an introduction, which basically introduces the characters and setting. Today, I am going to present to you the performance of company XYZ. Rising action, this includes articulating the problem being addressed or the questions being answered. I'm sure you're interested to know how XYZ has been performing this year in comparison to other years. Climax, the climax shows the results of the analytics that are being performed. So here, as you can see, due to COVID, company XYZ has experienced a sales decrease of 50%. Then you have your falling action. If the presentation has identified something negative, like a problem or risk, the falling action may include suggestions for improvements. Due to the decrease in sales, we have decided to pursue a different business strategy. So we are going to move to an online sales model where we deliver products directly to our customer rather than a retail sales model. Then you have the resolution, the end of the presentation. The audience is presented with a powerful call to action. What do you think about our new sales model? What are your thoughts? We believe we're able to increase sales by X. And then you have your decision maker looking at the information saying, yeah, this is a great idea, or no, this is a horrible idea. And here's just a visual representation of our story arc, our beginning, our middle, and our end. And that is it. I'm looking forward to seeing you in class. If you have any questions or concerns, please email me, and have a lovely day. Take care. Bye.